Good afternoon, class.
Good afternoon.
Are you good today?
Yeah.
Okay. So, actually, we will start today with an expression. How will you express yourself? So, although we are in mathematics, we also express ourselves. So, I'll be giving you expressions in mathematics wherein you will just guess. A wild guess if you don't have a basic idea first. But, of course, for those who are, I know, you're reading ahead of time, you would know it. So, I want you to put here, for this grouping, I'll group you as group 1. So, choose an expression from this algebraic expression, choose which is a polynomial. So, if you have an advanced reading, you would know it, but it's all right because it's just like an English expression. What expression do you want to be on your poster? So, we'll be making a poster, placards. For this group, Sean, Deborah. So choose at 3 among those 5 expressions. Choose 3 that you would include in your poster. Okay. Are you okay? Yeah, there are only 3 you would choose. So which do you think you would want to be included in your poster? Posters of mathematical sentences. Okay, and then paste it on your poster. Okay, so anyway, keep your other expressions and then just put it there on your table. You'll not need them, you'll also analyze them. So this is for group 1, they chose this. You have different anyway. Okay, so that's your choice. This is just a wild choice. If you are like lucky, you know. So here is your choice. Number 2. So these are mathematical sentences. Actually, expressions, they don't have a period yet. I stand corrected yet, okay? So with these expressions, which do you think is our lesson? So we have algebraic expressions. So what I ask you to choose are to choose which among those expressions are polynomials. Okay, so who would define them? So we would know which is that. So our objective is on the standards, interpret parts of an expression such as terms, factors, and coefficients. So your choices will have those. And so given an expression, tell whether it or not it is a polynomial. So which of those 5? So you think those that are left with you are not polynomial, and these are the polynomials. And then if this is a polynomial, then we would name it by degree and by the number of terms. And then in each term, we will see which is the numerical coefficient and which is the literal coefficient. So what are those terms? You have to it's not an English subject class. You have to define terms. Okay. So polynomials stand for real numbers and are algebraic expressions that involve only the operations of addition, subtraction, and multiplication. So those are the only ones. So let us analyze your choices. So addition and subtraction, it goes. But it is very literal and direct definition. It doesn't say here that it involves a square root. So this one, we'll remove from your and put it down here. So it's all right. We will later on, so which do you think will replace it? Yeah, because it doesn't say division. Okay, that's very good. Okay, so you have another term here. And what else? Let us also here, because you have addition and subtraction only. Okay, so you have polynomials. So expressions that are not polynomials are now in your table. This one involves a square root, so it's not a polynomial. And this one involves division, so it's not a polynomial. It has an exponent on it has a variable on its exponent, so it's not a polynomial. And absolute value, just like the square root, is not a polynomial. Okay, very good. So we have now the list of the polynomials which are now on your choices. Okay? So what about the other terms that we have to define? Like factors. What are factors? So these are in an expression are parts of the expression that are multiplied together. So if we will have this sample here, 3x squared plus y squared. So it means that there is these factors because the addition is in between. So we will consider only this multiplication process here. So on the 3x squared, the factors are 3x. 3 and x are the factors. And here, 1, although it's not written, it's understood that it is multiplied to 1. 1 and y are the factors. The degree of the polynomial, so as we have in our objectives, we have to define the degree of the polynomial. So the degree of the polynomial is the maximum number of variables that appear as factors in one term. So what do you think is the other, how we can define it again? If it is multiplied, like one variable, x, and then it's multiplied again to x, and it's multiplied again to x. Oh, x is always a multiplication. Anyway, let's choose a. A multiplied to a, multiplied to a, because that is what is said there. It is that variable will be multiplied as factors. So how many? So like a, instead of writing a times a, how would you write that? Yes, a to the third power, or a cubed. Correct. So it means this is the number of exponent. So the degree of the polynomial is the maximum number of exponent. To which number of exponent it is raised? If it is on the third degree, fourth, the third, as what we have said. Amber, can you please say it again? Instead of saying a times a times a cubed. Yes, so a cubed, the exponent 3. Okay, so that's the degree. So the same thing, we have the exponents here. So that this is the degree of the polynomial. But it says, like, it's so happen here that they are all to the second power. What if one of them is 3? So what will be the degree of this polynomial here? Yeah, cube, because it says it's the maximum. So it's the highest exponent. So in other words, this definition here can be reworded as the degree of the polynomial is the highest number of exponent. Okay. So I think that is a better definition. Because it has a low, shorter, smaller words with it. But of course, we will find it different on different books. So this, one of the references says this is the definition, okay, by Prentice Hall. So these degrees actually have names. So it depends on the terms that are on the polynomial. If it is only a number, then it's a constant. It has no exponent. It's raised to, yeah, so it's called a constant. The name of the degree is constant. So if there is a, this one, yeah, 0, 0, 1, if it is raised to 1, so then it's linear. That's the name, or the first degree. The second degree is called quadratic, and then the third degree is called the cubic, and if it is raised to 4, then it is quartic, and it's in the 5th power, then it is called quintic. So it's not in English, we have to memorize terms. So we have constant, linear, quadratic, cubic, quartic, and quintic. So it's it's easier to memorize a cubic. It's the cube. Okay? So another term which we have to memorize is the term itself. Terms and expressions that are parts of the expressions that are added or subtracted. So you would see what, how many terms you would know the polynomial is. You would see what is in between. It is supposed to be an addition or subtraction. Okay? So this a squared is one term, this 3b squared is another term, and this negative 2c squared is another term. So it says there that it has, this polynomial here has 3 terms. So the same with our, what we have done here. So how many terms you have here in your first expression?
3.
So you have three terms. Here,
2.
you have 2 terms, and the other one that you choose again?
1.
1, because there is no plus or minus in between it. So those are the cube that would let us know how many terms there are. So in your choice, how many terms do we have here?
3.
So we have 3 terms. The one that is in between is plus and minus. So 1, 2, 3. How many terms do we have here? 1. There is no plus or minus. This is a multiplication of all the variables. How many terms do we have here? 4. 1, 2, 3, 4. So it is a plus and a minus in between them. So these terms has also special names. So if it is only, that's just like that, your choice here. Like, oh, there's no plus or minus in between it. Because it's a monomial. It's only 1. Mono. So we can easily memorize that because of the mono is for 1. Similar, monomial. Okay? If it has 2 terms, like it has one operation which is only plus or minus in between, then we have 2 terms, and that is called a binomial. Oh, this is also easy to memorize. It's bi, means 2. So binomial. Oh, these names are easy to memorize because the third one is trinomial. Tri means 3. So the polynomial, which has 3 terms, is a trinomial. So many terms to memorize today, class. And then now, we have the so-called numerical coefficients. And these are the constant multiplicative factors in an expression. So, constant, so number, which is a number. So, on the first term, remember, the plus and the minus separates terms. So, the numerical coefficient of the first term is 1 because it is understood that a squared is multiplied to 1. And then on the 3b squared, the numerical coefficient is the 3. And on the third term, the numerical coefficient is the 2. Why didn't we say negative 2? It is because we are talking of the term itself, and the plus and the minus sign is the one that we know that which is the term, what separates the term. And from the definition of the polynomial, it is an addition, subtraction, and multiplication of variables. Okay? So, here, what is the numerical coefficient for your term here? 1. There's understood to be a 1 in here. The numerical coefficient here?
1.
Here?
3. 2.
Okay, you didn't say -2. Very good. Okay.
3. 1.
Yeah, understood to have a 1. You see the 1 there? You have glasses, you can see it. Okay, what about here?
2.
Okay. Oh, you didn't say -1. Very good. 1. So we only have one term and the numerical coefficient is 1. 3, 2, and 1. Okay, you didn't say again -1. It's 1 and 4. Okay. So we're talking only about a constant. The numerical coefficient. Another term we have to memorize is the literal coefficient. The word literal. From the literal, it means the letters. Correct? And then, so we have here, the letters are A, B, and C. Oh, this one is so nice. It's A, B, C. So here, what are the literal coefficients?
A and
Okay, A and B. A, B, C. Oh, how nice. It's just like a kindergarten.
X and Y.
Oh, see, that's but it is algebra. It's called the literal coefficients. X, Y, and Z. Okay? Oh, you have another variable here. M is M. Because the most used is the A and the B, X, and Y. We also actually can use any letters in the alphabet because it's literal. So you have M, N, A, B. Okay. So actually, the other term we have to memorize is the constant. But we already had it. Why? Because these are only the numerical coefficient. So the numerical coefficient is also called constant. It's a number representing only one number, such that the pi is a constant because it represents a fixed value. What is the value of a pi?
3.14.
Very good. 3.14. Are you sure it's not 2.14? Okay. So it's a fixed value. Okay, the pi is a fixed value. And then, so if you see a pi there, it belongs to the numerical coefficient. It is a constant. Okay. And R is R. Oh, see, we use another letter here. The R is the variable. Okay. Then variables are the literal coefficients that represent the various numbers. So if here, what are the variables in your group? Okay, so for A squared B, the variables are A and B. But okay. We always use, let's have just your monomial. So for your monomial here, what are the variables? A, B, and C. Okay. Okay, anyway. I have a question. We are talking about variables, correct? So what is the other term for that? Which is composed of two words? So we also call it the literal coefficient. Okay? So variables are just literal coefficient. And then for the constants, it's the numerical coefficient. Okay? Did you enjoy our terms? So, with that, let us have our, so we have already analyzed which are not polynomials in the expressions that we have. So let us recap. Why is this not a polynomial? Yeah, it is. It has a division. So from the definition of the polynomial, it is only multiplication of factors involving the process of addition and subtraction. And also, it has a value of a real number. So, if the value of this gives you a negative number, I mean, no, it's still real number if it's a negative number. But if it becomes complex, it becomes like if the value of the division would result into an imaginary number, then it is a complex number now. This is not a real number anymore. Then it will not be a polynomial. So again, why is this not a polynomial? Yeah, it involves the square root process wherein if the value of this a would result to a square root of a negative number, and the square root of a negative number is an imaginary number. So it involves now a complex number. So it does not belong now to the real number, so it is not a polynomial. But this one, as we said, is a polynomial. Because why?
It's using
Yeah, it's only using multiplication. And it also would have a real number value, and it goes with the definition of a polynomial. So, here. Oh, let us see the other expressions that are not polynomials. Why is this not a polynomial? Yes, it has a variable and its exponent, and it might result to an imaginary number resulting to complex number, and it's not a real number. So remember that polynomials are only real numbers involving the process of multiplication, addition, and subtraction of variables. So the more we repeat it, the more we memorize it. Like, why is this not a polynomial? Yeah, it's an absolute value, and it is not on the definition. But we stick to the definition. Okay, so we have polynomials. Your choices here are those that are polynomials. So, what are those terminologies that we have to memorize? Like, yeah, that is on, very good. That is on the definition of the polynomial. If it has had addition, subtraction, and multiplication of variables in a set of real numbers. Okay.